The tiny device here is the BMV080 particulate matter sensor from Bosch Sensortec. Compare it to this box, that's the kind of size of device that people would typically be using today to do particulate matter sensing. It has a chamber and a fan, and it's much, much bigger. So here we have the BMV080 mounted on a flex PCB. That's going to be a rather different matter to integrate that into an end product than this huge thing here. So embed here is going to explain to us how you go about integrating this small device into your end product.
What you're looking at here is the BMV, so the sensor component. It's where the lens is as well, and where the laser is emitted from. And you have then an area with passive elements, passive components, and then you have the stiffener, where you're supposed to handle the sensor from. And finally, where you're supposed to connect the sensor by the end ZIF connector.
Okay, and you mentioned the stiffener, so there are kind of careful sort of handling procedures here for. Yes. So you're meant to pick it up.
Tweezer or a vacuum pen.
Okay, because this is a very small, very delicate kind of.
You don't want to touch anywhere on the sensor or the PCB.
Okay. Excellent. So, and at the connector end, so that's a zero insertion force connector. So that's then compatible with standard ZIF receptacles?
There are standard third-party ZIF connectors which are compatible with our sensor, and we do mention them. Just to name a few examples, Molex has compatible ZIF connectors, also Kyocera and GreenCon.
Okay, so when people go looking at your documentation, they're going to find references to those.
In our data sheet, you have the recommended part numbers as well.
Okay. Okay, so this is a pretty small unit. So the dimensions of this are what, Ahmed?
So you have it's 4 by 3 by 20.
Okay, so really small.
Millimeters.
In millimeters, absolutely, yeah. And at one end, you've got a laser, an optical sensor. So I'm guessing that's producing quite a lot of heat.
That is true.
What does that mean in terms of the assembly?
Just to give you a perspective, this sensor, if it's running in continuous mode, it's giving a data point every 1 second.
Yeah.
And that, of course, generates quite a lot of heat. I mean, it's typical for optical sensor to generate heat. And in order to take care of that, you need a good thermal integration in order to dissipate this heat.
Yeah.
And in our reference design, we provide you with off-the-shelf accessories which you can use, such as basically thermal tapes or thermal pads which you use with the sensor to secure it in place and also to dissipate the heat.
Okay, excellent. And I think if this is right, then you also need to mount the sensor very securely within the enclosure in order to make sure it can measure accurately.
Yeah, I mean, like mechanical integration is key to having a secure sensor, stable sensor on your board, which ensures also the performance, that you have good performance. And to do that, you basically, to mechanically fix the sensor or secure the sensor in place, you need again the thermal tape and the thermal pad and under a plastic housing or a metal housing, ideally. And we again so in the reference we provide a reference design which goes over the recommendations which we have. We have 3D printed metal mechanical housing for which as examples. For instance, we have metal sheet housing as well as examples. But for every use case, it could be different. So you have different mechanical integration steps or techniques that you can use for every use case, and we cover that through our reference design recommendations and also our documentation. And also you have we provide CAD files like step files, for instance.
So, so someone who's using the BMV080, they've followed your advice, your guidelines around thermal integration. They're using thermal tape or whatever. Now they want to test that they've actually got the thermal design right.
Yeah.
How can they do that? How can they check that the
That's
device is operating properly?
That's a very important question. So what we do is we provide our customers with code snippets to test thermal integration. What it does, it checks the limits of the boundaries where the thermal temperature needs to be at, the sensor temperature. And based on that, it gives you an indication whether you have done the thermal integration correctly or not. And this can be also done at any stage of the design, whether you're in engineering validation test or production validation test. So you have quite flexibility when testing throughout the whole design process.
Okay, so throughout the development process, then you can be checking that the thermal performance of the device is within limits.
Is within the limits, and it's working as expected.
Very good. Yeah. So there you have it. If you're interested in using the BMV080 particulate matter sensor, if you have any questions around the thermal or mechanical integration of the sensor into your own product design, then that's all handled by reference designs and datasheet information provided by Bosch. So there's a ton of reasons why you'd be interested in exploring the features of the BMV080 particulate matter sensor, and you can do so with one of the shuttle boards. So Ahmed, maybe you can tell us, we've got can see the board here, you've got the sensor. I see it's behind an aperture with there's a dark ink glass and some headers and then some connectors underneath. So just tell us, how do you use this BMV080 shuttle board?
So the shuttle board is meant to be an early evaluation and also for proof of concept. You will find basically it connects to our application board, similar to our other shuttle boards which we have in our product portfolio.
So an application board is a board with a microcontroller on it and that can connect to a PC.
Also you can use it for BLE communications. Right, so it has a lot of features supported, and you can use it then for proof of concept. So you either use our drivers, we have readily available examples on GitHub, and additionally you can also plug and play. So we have also software supporting plug and play, where you can just plug and test the sensor and see outputs.
Okay, so you can plug this shuttle board into either one of your application boards or into your own proof of concept board, and you've got full software support for it as well, with PC and for support on a PC and application examples through GitHub and so on.
Yes.
And this board is available for anyone who wants it now?
Yes, and you can get it through our distribution partners.
Thank you.